So if I were to draw a circle, and I were to draw a radius of the circle, and I were to draw a tangent to the circle, what are you all supposed to know about this area right here? Perpendicular. When you see that, you must know perpendicular. Will I tell you? No, I will not. Okay? You need to know that. All right. The other concept, you had two concepts so far. The other concept had to do with the tangent from a point outside the circle. What if these two lines are tangent from this point? What do we know about those two segments? They are congruent. Those are the two things you have learned so far. And those I would study. Those need to be stuck in your heads. All right. We talked about what a chord of a circle was. It's a segment whose endpoints are on the circle. And that's what we explored on Friday before break. We named chords, etc. All right. So if two chords in the circle are congruent, then they determine two congruent what? I don't remember the order we did these in. Central angles. If two chords in a circle are congruent, then their arcs are congruent. Did we start this? I don't think we did. So this is section 12.2. All right. So this is the picture that I've got, and then we'll look at the little diagram below. Oh my, that just took it right out of everything. So if we've got I didn't want to do that either. This chord is congruent to this chord. Because of that, we know that this angle right here is congruent to that angle right there. We also know that this arc right here is congruent to that arc right there. We learned before break that this is 50 degrees. What is this arc? 50 degrees. The arc has a measure. So if this chord is congruent, what is this arc? 50 degrees. What is this angle? 50 degrees. All right, so this is the relationship that I was trying to make it as simple as possible. If I see congruent chords, I will look for what? You see equal chords, you will look for equal arcs, and you will look for equal central angles. If you're given equal central angles, what do you look for? Equal chords and equal arcs. If you're given equal arcs, what are you going to look for? Equal chords and equal central angles. So for a lot of what we did on Friday, this diagram basically is everything as concise as I can make it. So if you see congruent chords, you will look for equal central angles and equal arcs. It's like a triangle. you're given equal arcs, then you know their chords are congruent and you know the central angles are congruent. If you're given equal central angles, you know the chords are congruent, you know the arcs are congruent. I think this is a worthwhile diagram. I believe these are some problems. All right, so now E is the center of the circle. They have told us segment AB is congruent to segment DC. So before I ever even look at the problem, this chord is congruent to this chord. What does that tell me? Their arcs are equal, meaning arc AB is congruent to arc CD. What other piece of information do those two congruent chords tell me? They have congruent central angles. In other words, angle 1 is congruent to angle 2. So I don't go here until I look to see what I know. So then when we come over here and it says the measure of AB is 40, by the way, I have asked you to draw a picture on every single problem tonight. That is not optional. It's a must. All right, no, I will deduct a point if it's not done. If this arc is 40 degrees, what is this arc? This is 40 degrees. What is this angle? Central angle, vertex on the center is equal to its arc. And so what is angle 2? 40 degrees. They're not vertical, but they're equal because of the arc. So I've asked you for the measure of arc DC, which is 40. Could I have asked you for the measure of angle 1? Could I have asked you for the measure of angle 2? Just by giving you that 40. All right, so what I'm going to do now is see if I can undo what I just wrote. All right, so now measure of angle 1 is 88. If I know this is 88, what do I know about this arc? What is it? Sydney? 88. And if this arc is 88, what is this, Kayla Epps? 88, because we got congruent chords, we got congruent arcs. And if this is 88, what is this, Kayla? 88. So I have asked you for the measure of CD. What is CD? 88. Could I have asked you for a measure of angle 2? Could I have asked for the measure of angle 1? So on your homework tonight, it's just going to be, I'll give you an arc, I'll ask for an angle, I'll give you an angle, I may ask for the other arc. Is this hard so far? Okay. E is the center. Now I'm telling you that angle 1 is congruent to angle 2. What does that tell you? Given those two central angles congruent, what does that mean? The chords are congruent. What else? The arcs are also congruent. So just from this information, this is what I know, and this is what I'm going to mark on my circle. Now I'm going to go to my first problem. My first problem says if the measure of arc BAD is 215, and the measure of angle 2 is 120. Well, if the measure of angle 2 is 120, what's the measure of this arc? 120. What's the measure of this angle? 120. What's the measure of this arc? 120. Now, if the measure of the arc from B all the way through A to D is 215 degrees, how do I find the arc just here? Subtract. We say 215 minus 120. Do I need to see this work for credit? If you just give me an answer, will you get credit? No, 95 degrees. So this is a little bit more complex thinking because you had to know that equal angles had equal arcs, and that equal arc had to tell you that you needed that 120 in order to get there. All right, so let's take away this part of my picture. So now we have arc AB. Now we're back into the algebra. Is 6x minus 1, and DC is 3x plus 20. Notice I want to know what angle 1 is. What equation can you set up, Tommy? Three x plus 20. All right, and why did you say equals? Right, they're the same because their central angles are congruent. So if I subtract 3x and I add 1, I'll have 21 equals 3x. What is your x? All right, now you have to answer the question, measure of angle 1. Measure of angle 1 is equal to what? So we're going to say measure of angle 1 is going to be 6 times 7 minus 1, which is 42 minus 1, which is 41. So you're going to have arithmetic and you're going to have algebra. You'll have arithmetic and algebra on the next test also. MJ, are you awake? All right, so let's look at this picture. What does this tell us? What are those? Congruent what? Chords. What do congruent chords have? Equal arcs. What is this arc? So what must this arc be? 80. If this arc is 80 and this arc is 110 and this arc is 80, what's x? Is it? I don't know. How do you find it? It's 90? How do you find it? You say 80 plus 100 plus 80, I do believe is 260. Oh. Okay, how about 270? Does that mean x is 270? No, what is x? How did you get 90? You got to take your 360 minus your 270, and then you get your 90. So this arc right here is 90. This is the center of the circle. What's y? 90, because if you have an angle whose vertex is on the center, it's a central angle, and the central angle is equal to the arc. So here's another way that these congruent chords, congruent arc picture can come into play. All right, you've got two problems that I want you to do right now.